Good day, class, and welcome to our lesson 3 for week 3. And we'll be discussing the principle of network administration. I remain Adelani, your facilitator on this course. Let's roll. Objective. What are those things that you will learn at the end of this course? At the end of this teaching, at the end of this unit, you should be able to define what is a network administration. You should also be able to know the scope of network administration. You should also be able to understand the challenges of system administration. Then also, at least, you should be able to name 4 basic network topologies. Then, of course, you should be able to cite advantages and disadvantages of each type, that is, each type of network topology. And lastly, you should be able to state the criteria necessary for an effective and efficient network. As a form of introduction, we should know that network and distribution processes or processing systems are of critical and also they are growing importance in business, in government and other organizations. We should also know that network must be managed for effectiveness and efficiency. If you can't manage it in an effective way, I don't think then you should be a network administrator. What do we understand by network and system administration? We have 2 words here. We have network, then we also have system, all of them down to administration. We say a network is a branch of engineering that concerns the operational management of what? Of computer system. That is network administration or network administrator. It's a branch of engineering that concerns the operational management of computer system. Putting together a network of computers, that's also forms of network administration. When you put together a network of computers, that is, you have workstations, you have personal computers, you have supercomputers, and you put all of them together on a network, then there is a need for a system administrator, or that process, that operation is what is known as a network administration. Now, a system administrator should not just cater for one selfish need, but also he or she should work for the benefit of a whole community. When we talk about community here, we talk about the human interface, we talk about the computer interface. It should be able to work for the benefit of everything that is being put together. Then the term system administration is basically or traditionally being used by mainframe and Unix engineers. Why? That is to describe the management of computers, whether they are coupled by a network or not. Also, as in system administration or system administrator, the management of network infrastructure devices, that is the routers and the switches. This is a work of the system administrator, and this process is what we know as system administration. Now, what are the scope of network administration? What are the scope? That is the management of a network is usually called a network administration. The process of managing of a network is what we know as network administration. And this consists of procedures, consists of protocol and services that keep the network running properly. When we talk about network administration, we are also talking about the procedure, protocol, services that keeps the network functioning properly. We talked about efficiency, we talk about effectiveness here. Also, making sure that the network is always available, that is up and running. As the IT professionals, we always say, is the system up and running? So, as an IT professional, you should make sure that the network is up and running. As one of the scope of a network administration. Also, we have several other activities that network administration or network administrator, what he or she needs to do. He or she also needs to monitor the network capacity to ensure that all transmission requirements are met. All transmission requirements, all that it takes for a communication to take place. All these requirements must be met as a system network administrator. Then also adding capacity to the network by increasing the bandwidth. These are not separate words, but they are the same. It's a single word, bandwidth. Interconnecting additional modes or creating and connecting additional networks. That's also the activities, the scope of a network administrator. Then training is also, their scope also includes training people on how to use the network effectively, not for their own personal gain or their own personal selfish interest. Also assisting IT professionals in organizational application that will make good use of the network's capability. That includes the work of a network administrator. Also, their works also includes backing up the network software and data. It also includes putting security procedures in place to make certain that only authorized users have access to the network. Here we talk about authentication, here we talk about integrity, and also we talk about confidentiality, the CIA here. And also they make sure that network personnel can quickly respond to any security failure or operational failure. Then also they should be able to diagnose and troubleshoot problems on the network and determining the best course of action to take to solve them. All these are works or other activities of a network administrator. Now, what are the challenges? The challenges I am going to be talking about here, it has to do with planning and designing. The challenges has to do with planning and designing an efficient community of computers so that real user can be able to get their job done. So I'm looking at their challenges in terms of planning and in terms of designing an efficient or a formidable network. That is, designing a network which is logical and efficient. There is a challenge there. They find it difficult most of the time to design a network which is logical. You have to do a logical connection of systems together. What happens when you connect a dissimilar network, dissimilar devices on a network? How do you plan for that? Then deploying large numbers of machines, we can easily be upgraded later. There's a challenge there. How can you deploy very large numbers of systems? So there's a challenge there. And whether these services are needed, whether do you need this or you don't need this, is also a challenge. And also providing a comfortable environment for users. This is very, very problematic. You want to make sure that all the people working in your organization are comfortable. It's also a challenge. Then developing ways of fixing error. This is a very big challenge. How do you fix an error in the situation where you have 1,000 computers connected together and all are working up and running, and there is a problem in one of them? So you need to scan through the whole system. So there's a challenge there. Also, keeping track of and understanding how to use enormous amount of knowledge is a big challenge. An understanding of how data flows from machine to machine is essential, and as well an understanding of how each machine affects every other one. How do system A affect system B? How do system 1, 2, 3, 4, 5 affect system 100, 50, 30, and so on? How do they communicate? How do they transmit data? So all these listed items are just some of the challenges of system administration. Now let's look into some things more pointing to network, and that is network structure. So we'll be talking about the physical topology of network, which refers to the way in which a network is laid out physically. How a network is laid out physically. This physically, what you could see with your eyes, what you could feel with your hand, as a network structure, physical topology, where two or more devices connect to a link. When these two systems connect to a link, two or more links from a topology. When you have a particular topology connecting to another particular topology, those are the two devices coming together. The topology of a network is a geometric representation of the relationship of all the links and linking devices, which are always called nodes. As you can see here, these are category. This figure 1 shows the category of topology. You have different types of topology. There is a mesh, there is a star type, there is a bus type, there is a ring type, and there's also an hybrid type. To one another, there are 4 basic, which is in this figure 1. You have the mesh, you have the star, you have the bus, and you have the ring. There are 4 major types. The other one is the hybrid, which has to do with when you have a connection, a topology of this, matching it with a topology of this, then you have an hybrid topology. Let's go to mesh. Now, when we say mesh, what do we understand by the word by mesh? In a mesh topology, every device has a dedicated point-to-point link to every other device. That is, as you could see, this system, it has a point to this system, it has a point to this system, it has a point to this system, and it's even supposed to have a point to this system. As you could see, it has a point to 1, 2, 3 systems. So for this also, it has 2, it has 3, this has 2, this has 3, while this has 4. This station connects to all of them. The term dedicated means that the link carries traffic only between the two devices it connects. What this means is this message or data flow can only flow between these two systems. Can only flow between these two systems it connects. Then if it wants to flow data to here, it has to be with this system and this system. Whereas this system, if it wants to have an interaction here, it has a direct link to it. So we makes it a mesh. So all the systems, they all have link to themselves. So this is a mesh topology where each of all these systems, they have link to themselves. This isn't complete because there's no connection between this and this and some of other ones, but it's supposed to be all of them. Every device has a dedicated point to point link to every other devices. That's what we call mesh. That is, this system access to this, has access to this, has access to this, then this has access to this, to this, to this, and all of them to one another. That is a merge. What are the advantages over every other topology? The use of dedicated links guarantee, yes, the word guarantees that each connection can carry its own data load. That is, data moving from A to B is guaranteed. It carries its own. If one link becomes unavailable, it does not incapacitate the entire system. If for example an information is supposed to move from this to this and this line is not available, does not mean that there won't be any connection. This one still have access to this and information could still be reached here, and this have access to this, and this could have a cache, or a form of residual information with which this one can still have access to this. So you can see, but if let's use this as an example, this to this has no information, but this to this they have information, and this to this has information. This could still see some element of information of this in this if it is configured that way. Let's go for that. The advantage of privacy and security. Yes, privacy and security is a very good advantage of mesh topology. Then point-to-point link makes fault identification and fault isolation easy. If there's no data information between A and B, easily as a network administrator, you can easily detect the fault and amend the error. Well, let's look at the disadvantages. Every devices must be connected to every other device. Installation and reconnection are very, very difficult. Yes, you have 5 systems. It means they will be connected like 5 times 5, that's 25. So you see the mass. So it's a very big work. That's just for 5 systems. Then you have a bulk of wire can be greater than available space. So you have wire running to and fro, number 1, to and fro, number 2. Then each of them like that, they connect to each other. Hardware required to connect each link. Talking of the times of ports, cables, and they can be very, very expensive. These are just the disadvantage. Now what about star? As you could see, a star, you have something which is a central of them, like a hub, which connect this station to the hub, this station to the hub, this station to the hub, this station to the hub. Each device has a dedicated point to point. link only to a central controller, which is usually called hub. This is a point here that it has inside this hub. This one has its own, has its own, has its own. Devices are not directly linked to one another. They are not directly linked to one another. Before an information, this could get information from here, it has to relate with this hub before it can have access to this information. It doesn't have access direct to that station. It does not allow direct traffic between devices. This and this cannot communicate. You have to tell the hub before you can receive information from this system A. The controller acts as an exchange. The hub, which is the controller, acts as an exchange of data. If one device wants to send data to another, it sends the data to the controller, which then relay the data to the other connected devices. This guy wants to send information to all these three. It has to send information to the hub. This is the controller who will now disseminate the information to the others on the network. Now, what about the bus? You can see the word BUS, bus. You can see the way it is, just like on a straight long line. Nodes are connected to the bus cable by drop line or hand taps. This connected to this side, this node, this connect to this node, this connect to this node. A drop line is a connection running between the device and the main cable. See, this is the main cable, and there are nodes on it which connect to each of all these stations, the bus way. Now, a tap is a connector that either splays into the main cable or punctures the sheet link of the cable to create a contact with the metallic core. This adds to connect in here, inside there, to be able to make data connection. As a signal travels along the backbone, some of its energy is transformed into heat. As it moves, there is a form of heat generation as the data moves to and fro. A limit on the number of taps a bus can supply and on the distance between those taps. There is a limit that you can have on those taps, which you can have on the bus. So you can see what it is. You can see the disadvantage, even right from what we said, the heat generation. Now let's look at the ring. The ring topology. You can see it's in form of a circle. You can see a station, and you can see in between them you have repeaters. Now let's look detailed into it. Each device has a dedicated point-to-point connection with only the two devices on either side of it. Each device has a dedicated point-to-point. Then a signal is passed along the ring in one direction from device to device until it reaches its destination. For example, you want to send information to this. You first of all send it like this to this one. When this one processes it to this one, when this processes to this one. And see, it has to pass through two other systems before it can get to this system information. Unlike the one for mesh will just send it directly. Boom, it goes. Then unlike the star, if you want to send information, send it to the controller. Then from the controller to the other one. But this is in form of jumping from one system to the other. Each device in the ring incorporates a repeater. Yes, it has a repeater who repeats the information to this. Now this repeats the information down to this. When a device receives a signal intended for another device, it regenerates the bits and passes them along. As I've just explained, sending information to this, you send it to here, and this repeats the message before it gets to this other one. Now we look at the hybrid topology. A network can be hybrid. For example, a star topology. You know what a star is. You can see this is an example of a star. This is a star. This is an example of a star. You have the hub here, with each branch connecting several stations in a bus topology. This is a bus topology. This is another bus. This is another bus. Then all these bus now has what? A star topology. So this is an example of an hybrid topology. So I want to believe that we've learned one or two things in this class as a form of as a form of revision. We've defined what a network is, a network administration, who is a network administrator, and what is network administration. We've also seen the scope of the network administrator or the scope of network administration, and we've also understand some challenges of system administration, and also we've looked into more than 4 network topologies. We've also cited advantages and disadvantages of each of the 5 network topology that we've talked about. Then we also stated some things, the criteria necessary for effective and what efficient network topology. So at the end of this class now, there will be an assignment which will be given to us. So I'd like to say a very big thank you for listening. Thank you and God bless you. Thank you.